have that copied down correctly? I think I do. Now, all of a sudden, you may open up the quiz tonight or the exam next Wednesday, you see one like that. It says solve. In this case, solve for y. Now, with what we've done in class, I'll sort of get some input from you guys also. I think we're looking for a common denominator.
Yeah.
And also, I think on the 7 over y squared minus 3y plus 2, guys, your factoring skills must be good here. I think this would factor, which will help, into y subtract 2 and y subtract y. 1. Is that true?
Yeah.
Which helps me because I see those two in the red match up with these, which is the best thing you ever run into on one of these. Now, step 1, I need to now put everything over a common denominator. And my common denominator is the red. So if I go back to the first term, it's missing the y subtract 1. That means I must put it in. The next term on the right-hand side, 1 over y subtract 1, that's missing y subtract 2, got to put it in. And of course, the 7 is in good shape. Now, all I need to worry about is on those numerators. Now, distributive property on the first one, distribute to 3, you end up with 3y subtract 3. No problem. On the right-hand side, my goodness, the first term is that. Merely y subtract 2, and the last term, 7. Is that true? Now look how much easier that looks than what the original problem looked like. Well, we just cleaned it up with a common denominator. Now, a student was asking, the reason I brought this in, I'll put this on the handout. The student was asking, Professor, how about these down here? How about that y subtract 2 times y subtract 1? Where's it? You just placed down here for us, you just placed all this on top, the numerators. Numerator, numerator, numerator. Anyone tell me what happened to my denominators?
Cancel out.
They do cancel out. So you actually multiply both sides by that denominator and it will all cancel out. So all you need to worry about on one like this are the numerators. Now to finish this up, no problem now. I hope I don't make a mistake. Let's start moving things around. Let's move that y over by subtracting. You end up with 2y. 3y subtract y. I do see I can move this 3 over. Maybe a little messy here, guys. I already have over here 5. Negative 2 plus 7 is 5. I'm moving over with it plus 3. I think we end up with 8. If you guys agree. And then divide by 2. Are you kidding? There's the answer. In no time. And I think I worked some of these in class also. I thought about this. Now, what would be really, really, really aggravating would be if I must reject an answer. That's where I will be asking. Also on the quiz, I'll probably be asking here, what could y not be at the very beginning in the blue? Can anyone take a look at this and tell me what could y not be if I should get it? I heard, what, 2? And 1. And for what reason? Those two would make a 0 denominator if I should replace. And I can never have a 0 denominator. Thank goodness, guys, I did not get one of those numbers. If I did, I would have to reject it. I got this, and therefore the final answer is 4. And I like my answers placed like this. It's up to you. You can see it. And there it is. It's done. So a student was asking, I thought I'd bring that in on the handout. Another one that I should, in the time we have here, yes, number 3 on part 2. I have 2m squared, 2m squared, subtract 2m, subtract 1, is equal to 0. I'm asking for it to be solved, find the answers. And guys, I think I want this one done by completion of the square. Here we go with that completion of the square again. Oh my goodness. Make sure I copied this down correctly, guys. You guys in my 4 o'clock session saw a couple of these worked out. I had students come up and help us. The issue first is that leading coefficient must be a 1, or completion of the square cannot be used. Now, can I quickly turn that into a 1? I can if I easily do this. divide both sides by 2. If I do, be very careful. We're going to end up with m squared minus m minus, of all things, 1/2 is equal to 0. If you go up and divide each one of these terms by 2, of course, 0 divided by 2 is 0. Do we agree with that? That's step 1 of this completion of the square. Leading coefficient is a 1. Now, I would suggest, this is my method, I'm going to leave the m's where they are and show that I intend to add something or complete it. And I'm going to move the 1/2 over to the other side out of the way, since it has no m with it. But show also I must add that same number to the other side to keep things balanced. Just setting this up. Now, after all that hard work, don't miss it. Because if we place the wrong number in that blank, that's going to throw everything off. So how am I going to find that right replacement? I need to take 1/2 of this coefficient. We'll find out what that coefficient is here. And after I do 1/2 of that coefficient squared. And by the way, guys, what's understood to be the coefficient of the m? What's understood to be the numbers out front, the coefficient, they call it, of m?
1.
-1, let's call it -1. And if you do that, guys, take 1/2 of that, of course, you end up with -1/2. Put a little comma here, that's not the number you add. You gotta take that now and squared. Now, 1/4, that's my number I need on both sides. Again, if you place the wrong number on the blank, I can't do much for you. You're gonna lose some points. Okay, guys, step 3, if all that is correct, I might think next that all this left-hand side should be a nice, perfect square, and that's why they call it completion of the square. You gotta come up with a square. Guys, we'll write this like this. Now, can anyone tell me what would that left-hand side look like factored into a nice, perfect square? Who has an idea? All this.
Minus half.
M minus 1, that's gotta be. It's gotta be. You square m, you get m squared. You square 1/2, you get 1/4. And if you do the whole thing by FOIL or expand this thing out, you also get that minus m. But the key points are these two. Gotta be those. The other side is arithmetic. And we all mess up on arithmetic. I mean, we all do. Put those two together with the common denominator of 4, guys. I think we'll end up with 3/4, is it? I think. You guys agree? Is it 3/4? With the common denominator. Now, step 4, we're about to finish this up. Step 4, we're now ready in an attempt to solve for m. Take a square root. Just be patient there. Okay, guys, the square root of the left-hand side is very nice. It's m minus 1/2. Has to be. Make sure you put a plus minus on the other side to ensure I get 2 answers, because the original was a quadratic. Now, what can I say about square root 3/4?
That would be √3/2.
Root 3, I heard. Root 3, nothing to be said there, but she's telling me root 4, or square root 4, is 2. At least I can do that. Now, last step, you get the m by itself. They ask you to solve for m. Guys, on the side here, you put it so everyone can see it. Move that 1/2 over. You're going to end up with m is equal to, we show it like this. 1/2 moved over. Still got the plus minus. Radical 3 over 2. I would express it like this. That's the answer, or answers. I think it looks better like this. 1 plus minus radical 3 all over the common denominator of 2, and let that serve as, if we have no mistake, as the answers. And we did it by completion of the square. Are we okay with that? Okay, so don't let this completion of the square frighten you. Now, I told the 4 o'clock session before I close this down, you'll have some time on the exam next Wednesday. The exam's going to be nearly 2 hours. On the exam next Wednesday, it's going to be a big chunk of our time. What I would do, I'd go back to the wait, Professor. Suppose I redo it already done what you asked me to do by completion of the square. Suppose I go back and redo it by using quadratic formula, just for the sake of myself, and see if I get the same answer. Let me do it real quickly since I'm here. If you did this by quadratic formula, here we go. M is gonna be equal to, oh, that's better. Negative b, negative and negative 2, plus minus square root, negative 2 squared, b squared, subtract 4 times 2, down to negative 1, all over 2 times 2. Negative b plus minus square root b squared minus 4ac, and make sure my numbers in there, all over 2a. Did I put those in correctly? And this becomes what? 2 plus minus, now put it over here. Underneath that square root's a little tricky. I know the first term is 4, negative 2 squared. The remaining part, I think you multiply all that out, I think it's a positive 8, is it? I think it's a positive 8. And all that's over 4. Bring this up a little further, this becomes a negative 2 plus minus 12. 4 plus 8. 12's not perfect. Can anyone tell me what 12 might look like, though simplified the best I can?
2 root 3.
I got you. So this becomes negative 2 plus minus. Now I heard 2 root 3. Still looking for it. And guys, that radical 12, I think my student was thinking about to get that answer. 4 times 3 can be expressed as 12, and square root 4 gives you the 2. That's what you stated.
Professor, isn't that negative 2 supposed to be positive?
It's negative b, and where's the b?
Because it's like a negative and a
Oh,
negative.
right here, right here. Come right here. Thank you. Is that true, guys? Is that the 2 you're talking about?
Yeah.
Is that good enough? Now, am I finished entirely if I were going to do it by quadratic formula? No, I think I can simplify this by what? Reducing these numbers down? And guys, if I divide all those numbers by 2, 2 divided by 2, of course, is 1 out front, plus minus 2 divided by 2 again is another 1 with that radical 3. And finally, the denominator 4 divided by 2 is 2. Please tell me, are they the same answers? So I just redid it by quadratic formulas just for a little check. And they gave me the same answer I got by completion of the square. Okay. So I point that out, guys, before I jump into where it should be. Seems like there's something else I want to point out. Oh, there is. Of course there is. Here it goes. Next, on the side here. To solve this, I made that real quickly, so I may have to change something. We'll see what happens here. This is an inequality. In fact, it's a quadratic inequality. Now, Monday, when I saw you guys last time, I mentioned something called sign analysis, but I think I mentioned it right near the end of class. So that's why I brought this in, just in case you see it. It's not hard, but it's a different process. First, guys, I think, let me check and see, will this factor? I hope it will. 2x, x, minus 1 plus 1. Let me step back and see how strong my factoring skills are. I think it does factor. Factors into that. You guys agree? It does factor. Now, if I want to solve this, by the way, guys, please tell, I'll tell you, the 4 o'clock session, I reminded them, if that had been equals, you'd quickly say this. Professor, split each one of these factors up. Set each one equal to 0, called 0 product property. And you're going to end up with right quickly this and this. And you're finished. You'll be finished. In place of your set notation and your numbers inside, you're finished. Well, too bad it wasn't. It did not say equal to, it said this. there's a little bit more to be done here. And what that little bit is merely go to a number line, it's called sign analysis. Go to a number line, place those answers, -1/2 and 1. So I just find them on that number line. Look back at your inequality symbol. I don't see an equals mark on this one. It says those two that came out can be used, cannot be used, so they're open. Because the equals, right here at that, was missing. So they're not to be included. And those are the answers from that equation placed on the number line. Now I need to know where to shade in. This is where you start testing. You gotta show me all of this when I ask for sign analysis. So let's test out here, here, here. I don't care what number, but you gotta show me that you choose. Out to the left of -1/2 is an infinite number of numbers. Guys, we'll try -3. Between -1/2 and 1, let's try 0. Out to the right of 1, let's try maybe 5. And those are selected by you, the test numbers. And now what you do, you test. Where am I gonna test? Right here. And all I'm looking for is, and again, they call this sign analysis. Using signs here. Okay guys, my first test number in the green is -3, so you're gonna take a -3 back and replace x by -3 in each one of these factors. Now do it in the first one, 2 times the -3 is a -6, -6 plus 1 is a -5. I'm just concerned about the negative, I'm just concerned about the sign. Second factor, replace x by -3 again, that's a -3 minus 1, that's a -4. Another negative, and those two multiplied together would be a positive. Now, is that what I was looking for?
Yeah.
The symbol on the right-hand side there says what, greater than 0? And if you're out to the right of 0, or you're into the positive territory, greater than 0, that says you have discovered immediately part of the answer. All this works. I've seen some of these where the entire number line works. 0, I'm testing 0, put a 0 here, 2 times 0, 0 plus 1 gives me a 1, which is positive. 0 here, 0 subtract 1 gives me a -1, negative. And I know altogether that's a negative, and I cannot use it, not for this problem. 5 may work, let's try 5, 2 times 5 is 10, plus 1 is 11, that's positive. 5 subtract 1 gives me a 4 in that second factor, positive. And those two multiplied together is a positive, and that's exactly what this says I'm looking for. So all this is also in the answer. Is that true? And this is all called sign analysis. It's not hard. A little lengthy. Now, can someone tell me in interval notation, be careful, how to express this? Oh, I see hands going up. Wow, 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 wow. Over it.
It's more than negative 1 over 2.
Okay, x is less than?
Yeah, that's
Okay, now we use this right here, guys. X is less than -1/2. I will accept that. It's not interval notation yet. Now tell me more. What's the other side?
it's larger than 1.
Or x is greater than 1. That's correct. But if I say it's now placed in this thing called interval notation, how are you going to express everything to the left of -1/2 and use this process called interval notation? Yes?
Parentheses, negative infinite, -1 over 2,
Beautiful. Hang on right there.
and union.
Union. It's like a U.
Parentheses, 1,
Okay, parenthesis 1.
infinite,
There you go.
and parentheses.
There's the answer. And we like in higher math to use interval notation. To make sure you know how to express this using interval notation. Okay, guys? Now I feel better about the quiz. I feel better about the exam. How'd you do it for you though? Any concerns, guys, about what I did here? Just want to do a little quick, a little quick recap. Okay, which I think is going to help. Okay. Now, let me erase this. I have, with the help of students, you guys are emailing me and asking me about problems, I love. I love to see what you guys are asking about. Erase this to get ready. Mr. Park, I heard from one of my former students, he's coming in to visit next week, so I asked him to maybe come in here and talk to the students for a few minutes. If he shows up, he sent me an email saying he's gonna be on campus next week. Guys, here's what I saw, or heard from students. Part one. Solve. Now, this is what I heard. Let me see if this class is going to realize what on earth professor is going on here. First, here it is. This. Solve that for x. In other words, when is that statement true? Guys, let me give you just a few seconds. Look at it. And tell me what the answer is. X squared subtract 6x plus 9 greater than 0. And they want you to know what x replacements would make that statement true. What can I replace x by and be guaranteed that statement's true? Think about it. Stop. Did any student, or these solutions here, did any student, look at it carefully, beautiful. Did any student discover that that statement's always true except for one number? You may replace x by any number you wish, sit there forever. And replace x by number after number after number, and that statement up there will be true, except for one number. Now, we'll see why here shortly, but I will get some input. Who thinks they know what that one, look at those hands went up. One number is, yes, in the back. Right, yeah, have you moved? Yeah.
Oh, 3.
3. 3, it will not work for 3. If I should, with his 3, replace x by 3 real quickly and just calculate, I see 3 squared is 9. Put a 3 here, that's 18. So 9 subtract 18, that's a negative 9 right there. The negative 9 plus the 9 on the end gives me a what? 0. But we want numbers that will give me a response of what? Something greater than 0. So 3's not gonna work. Everything else works. They said, Professor, you don't have the time to replace x by all these numbers, do you, Professor, to check all these? No, you don't. So there must be some process that shows me they all work. First, I and you would recognize right quickly, this will factor. In fact, it factors into this. You guys use FOIL? X subtract 3 times x subtract 3. Better yet, it's this. It's x subtract 3 squared. Now let's use a little common sense. Not math, just a little common sense. That left-hand side, whatever comes out on the left-hand side is being squared. If you square a number, are you expecting, if you square it, no matter whether it's positive, negative, whatever, if you square it, are you expecting a positive response to come out? That's all the statement says. Is this side always going to be greater than 0, which implies positive? Except for 3. If you put a 3 in there, you get exactly 0. Then what's greater than 0? So here, x cannot be 3. Now, the reason I brought this in, can a clever student tell me what's that answer look like using interval notation? Trying to show someone in a calc class you cannot use 3. You can use anything else, but you can't use 3. How's that look in interval notation? I see a hand going up. Yes?
Negative infinity to 3, union 3 to.
Perfect. Perfect. There's where you're telling someone you cannot use 3. If they say put in interval notation, this is the way it looks. That's showing you cannot use 3. Done. Another one. Before I jump into all I need to do here, this one. We want to use a little common sense on this one. But look at it, try it, see what you think. 2 over x subtract 4, and you want the result to come out to be negative, less than 0. What can I replace x by to assure that that left-hand side is always going to be negative? Okay, hang on. Now, if I were a student and the professor started throwing these questions at me, I might say, well, Professor, can you not multiply both sides by maybe x minus 4? Just multiply both sides by x minus 4, and the x minus 4 then cancel on the left. On the right-hand side, 0 times x minus 4, if I should do that, gives me a 0. 0 times anything. And you're going to end up with some type of a nonsense statement. Must be something else here that sometimes I love math, but sometimes it's just right there staring at you, and all of a sudden, you say, really, Professor, that's all they wanted. Professor, I was going to do half a sheet of paper to solve that. Is there an easier way to approach this? And so aggravating sometimes there is on this one. Now, here's what we'll look at. I thought, hang on just 1 second. Guys, a little common sense. That's a fraction. The top, the numerator of the fraction is positive, positive 2. What must the denominator, which is the x subtract 4, what must it be so all together, all this comes out to be a negative, less than 0? You know the top's positive. So what must the bottom part, the denominator, be so all together you get an answer of less than 0, which is negative? What must that be down here then? That's going to be negative. So that tells me that x subtract 4 wrote like this. That denominator must be representing something negative, written like that. So then I'd have a positive over a negative, which they want. They want a negative response, which is less than 0. That's what they imply. Solve this. Are you kidding? There's the answer. That's the answer. I didn't do math, just answer. this in interval notation would be a negative infinity up to, what's that, 4?
4.
Open. And you're done. Now, before I take questions on this one, suppose I get outside my answer, outside my interval. I notice 5. 5 should not work. I'll quickly take 5 back and put it in and see why would, for an example, 5 not work. It's not part of the answer. I go back and put a 5 in, this becomes 2 over 5, subtract 4 is 1. 2 over 1. That's 2. Is 2 less than 0?
No.
That would not satisfy the original problem. Those I have right there answered this. All these should work. Take any of these back to the original, put them in, they should work. And we got just about really observation here. Go for it.
From a mathematical perspective, can you just multiply both sides by 1/2?
Okay, let me do this. We're finished with this. You're saying this. And after what you said can be done, that's why I love students who use input here. She said, Professor, could I do this? As long as I do it on both sides. Multiply both sides by 1/2. You could. Oh, by the way, is that a positive 1/2?
Yeah.
It is, isn't it? So I need not worry about that symbol reversing on me. I'm not multiplying by a negative, so I'm safe there. She wants these 2's to cancel, so she's going to end up with that. And of course, on the other side, 0 times 1/2, 1/2 times 0 is still 0. You would end up with that. You could do that. And then maybe use a little common sense like we did over here to begin with, and you go from there and get the same answer. Is that true? Oh, by the way, if I did that, for a negative answer, so this must be negative, like this. Since the numerator is positive, and then solve it, and you get the same answer. Isn't that crazy? Are you talking about aggravating? After you take an exam in here, and I've seen students do this, you'll walk out in the hallway, and you'll start talking, what'd you get for that one? I got 3. What'd you get? I got -2. What'd you get? I left it out. Then all of a sudden you come back to where I leave, say, Professor, please, we're all getting different answers on problem number 3. What was the answer? And I'll give you an answer, know about it. Don't let that happen. That doesn't happen, it does happen. It does happen. But students will start comparing answers here. Guys, I thought I'd point some of those out before that quiz comes up, just out of curiosity to see what's going on here. I like these problems here. Okay, that said, I think I have one more before I jump into the functions, which you're going to love. I'll probably get to it. I think I have one more that I saw on a diagnostic test. I think you guys, oh, I did. This is my last one. X over 3x subtract 5 is less than or equal to 2 over x minus 1. Inequalities. We're going to solve for x. Now this one, there is no shortcut. I've got to do some work myself on this one. This is not one where I need to look at it. Any ideas?
Proportions,
So again,
proportion.
like what?
So multiply the denominator with the x to the.
Oh, you want common denominator?
No, not the common
You're saying cross multiply.
I mean cross multiply.
Can't do it.
No,
No, you know why?
because
I don't know what x is.
Because it's inequality.
If x were a negative, I don't know what x is. If x were a negative, you multiply both sides by a negative, this symbol is going to reverse.
That would be.
I don't know what x is. If x is positive, then what you're saying I could do. But they didn't guarantee me x is positive. They just said x. So if it were a negative, you multiply both sides by a negative, that symbol's going to reverse on me. I need another method. I see why you said that though. Guys, anyone see another method? As we clean this up. And like I said, they had this on a diagnostic test. The San Diego test. That's the end. Go for it.
You move, 2 over x minus 1 to the other
He
side.
wants that 0 that we've been working with on one side. He says, move that over. X over 3x minus 5. And guys, if I move it over, it becomes minus 2 over x minus 1 less than or equal to, there comes that 0. I just said move that term over, and I did. Now it might be wise to do what with those two terms? Come up with a common denominator and put them together. Guys, I see by common denominator, and I hope you guys can see it. Does everyone think they know what the common denominator must be to put those two fractions in the room together? What would I be using for a common denominator? Who has an idea?
Multiply just both.
Both of them? 3x subtract 5 must be used. And she's telling me times what? X minus 1, that's my common denominator. If I intend to put both of them together, I gotta have both. Now what's missing? If I want to use the common denominator, this one's missing the x subtract 1. Let me put that in. The second fraction is missing the 3x subtract 5. I put it in. Now everything is good. Everything's over the same denominator. Now let's clean up those numerators. Guys, right here, be very careful. Distributive property will give me x squared subtract x. That's the workup right there. Next, I see, let me erase this so you can see it. Left over is that. I got the first part done. X times x minus 1 is x squared minus x. Guys, if I use a distributive property with a -2 on this, don't let me make a mistake. -6x is at plus 10. This right here, multiplied out by -2. -2 distributive property. I'm right on top of the board. Is that it? -6x plus 10? Is it? Okay, I'm bringing it up here so you guys can see it. Right now I have x squared minus 7x plus 10. I have to look at some like terms. Over this. And all this is supposed to be less than or equal to 0. Let's hope there's no mistake. I don't know if there's a mistake in there. Oh my goodness. You guys will appreciate so much when we start functions. Now, does anyone have an idea? Because eventually I gotta solve this thing. But is there anything else to do? Can you believe we started out with this mess? And we're now into, where was that? This one down here. Start out with this, now we may look like that. Go for it.
Factor in the numerator.
The numerator will factor. We'll factor into, and put down here, help me out since you said, it's going to factor, what will that factor, or those factors be?
X minus 5.
X minus 5, x minus 2. This right here, factors. She's exactly right. The denominator, can't do much with it, leave it. We're going to be leaving all this shortly here. Now, block this off. That's all I see to do with it at this moment. Make sure everything's copied down the paper. Now, the reason I brought this in, one of the toughest problems. I see why they placed this on the diagnostic test. Any ideas? We got to solve for x. I see hands going up, and we're going to hit here shortly. You're going to be shocked at what we've got to do. A process we've already used in class, but we'll go back to it on this one also. Yes?
I have a question.
Sure.
Because at the beginning, I made it a common denominator. So at the very beginning, I just
Oh, right here.
yeah, right there.
You do that?
And so so I got rid, right now you have the denominator of 3x minus 5 and then x minus 1. So when I made it a common denominator at the beginning, I got rid of that.
Oh, good. You thought that common denominator would just drop out like it's been dropping out for us earlier.
Yeah.
That drops out only when, guys?
Is the only one you
When it's an equation.
okay.
If it's an inequality, oh, good question. Yeah, she said, oh, Professor, I thought I saw those dropping out for equations. They do. Here, though, it sticks right with me on this inequality. Good question. Guys, we're down to here. This is a mess. Bear with me. means draw a number line. Now, before you tell me, I will tell you, there are 4 points to be placed on that number line. And then I gotta start testing. Does anyone have an idea what any of those 4 points might be? And I'll start placing. 5, hang on, 5 for sure, I'll put it right here. And 2, I'll put it here.
3 fifths.
Look at that,
5
5 thirds.
5 thirds.
5 thirds, that's what, 1 2/3? So it's gonna go here. 5 thirds. 5 2. And also, 1. Guys, will 1 go here? Do I have all those, properly placed? 1 2/3, 2 and 5, I do, don't I? Are they placed correctly? On the number line, all 4? Now, beautiful. You get to go through and find all 4 in this one for sign analysis. Now, tell me someone in clever class before I start testing to close this down. I'll tell you this much. Oh yeah. 2 are open, 2 are closed. In other words, 2 will be darkened in, 2 will be open. So really they cannot be used in this particular, for an answer in this particular problem here. Can you first tell me which 2 do you think will be closed?
5 and 2.
Let me again.
5 and 2.
5, hang on, 5, closed in, and I heard 2. Why?
Because in the numerator will be remain 0.
If I replace x by 5, right here, that becomes 0. And this says if it's less than or equal to, could be equal to 0, you may accept it. So if I replace x by 5, I get 0. And also if I replace x by what, 2, I get 0. Now if that equals marker was missing, it's right here, I could not darken those in. They would be open, but they had an equals mark there. Now which 2, or the remaining 2, must be open, but then we'll have a student tell me why. 1 must be open, not to be included. 5 thirds. Open. Anyone tell me why those 2 must be open? Yes?
It'll be the denominator, that's right.
That would make a denominator of 0. And I can never have a denominator of 0. So if you replace x by either one of those, you get a 0 denominator. Now, we're not gonna do all this together because we're running out of time here. Next step, sign analysis. Look at this. You got a test here, here, there, here, there. And after you see all that to be done, you may say, Professor, are you teaching this during the winter? Maybe I should see you in the winter session. Because this is getting a little crazy, Professor. I've got quite a few numbers. I got a test on this one. Now, the sad thing is, I'm hoping it doesn't do this. The sad thing is, would it be horrible if I went through his test and nothing works? And the only thing that would work right now, if nothing works by testing, would be those 2 I have darkened in. You can say, Professor, the only 2 answers are 2 and 5. Nothing works. Let's see. Guys, here goes. To the left of 1, let's try 0. Between 1 and 1 2/3, oh boy. What can I try from 1 up to 5 thirds, which is 1 2/3? Give me a number.
1 and 1/3.
1 and 1/3? 1 and 1/3. So I guess it's 4 thirds. Between 5 thirds and 2, look how crazy this is. Now between what? 1 and 2/3 and 2. Anyone have a test number? So that falls between 1 and 2/3 and 2. And before you give me 1, I'll tell you there's an infinite number of numbers between them. There's an infinite number of possibilities. You just have to show me 1. Call between 1 and 2/3 and 2.
11 for 6.
Tell me again. I heard someone say it.
11 for 6.
Okay, look at this. I'm gonna get it now. 5 thirds, 2. I'm gonna write 2 as 6 thirds. I heard, somebody give me, what number was it again?
11/6.
11/6. I'm hearing 11/6 is a professor. How on earth do you know 11/6 falls between those two? Let's write this as 10/6. 12/6. Just multiply by 2, make it look like that. And then here's 11/6 would fit. See what's going on here? Diagnostic test. Now, I'm not gonna show you the answer here. It's gonna take a little bit of time here. But even just choosing, I'll choose one for you here. Between 2 and 5, I can try 3. Finally. And after the right of 5, I'll do that one for you. Try maybe 7. Now what I'm supposed to do, I'm supposed to be patient and go back. Look at this, place x by, x by, x by, x by, and hope you get some number negative. So I can shade it. Whew. Is that gonna take a little bit of effort?
Yeah.
Okay, now I'm not gonna do it all. Hang on just one second, I'm not gonna do it all. Hang on. Let me test one, just one for you. Let's try between 2 and 5. We'll test 3. If I put a 3 in, back up here. 3 subtract 5, negative, -2. 3 subtract 2, 1, positive. In my denominator, I'm testing 3. 3 times 3 is 9, subtract 5, that's a 4, that's a positive. Don't let me make a mistake here. And 3 subtract 1 is a positive 2. That's positive. Guys, what is that all together from algebra? Is that negative? I'm thinking negative times a positive is a negative. And on the bottom there, positive times a positive is a positive. So you end up with what? Negative over a positive? You're just going to give me a negative? Does that say that's what I was looking for?
Uh-huh.
That's part of the answer. Then you would have to be patient. I mean, patient, and test the answers. I'm not gonna test them for you. I want to work this out though. Go for it.
I was just wondering, I wanted to ask my interval notation for it, correct?
Oh, you can have the complete answer.
Yeah.
You've already tested all those intervals.
Yeah.
Was this one of the intervals?
Yeah, I mean, I did 4 instead of 3, but.
That's okay, but it cannot be the same interval I have up here.
Yep.
Okay, hang on a second. So we know 2 to 5 works. Now he's telling me, guys, tell me what you got.
I have parentheses 1, comma, 503.
Oh, this works?
Uh,
Hang on, I didn't test it myself, guys.
yeah, it does,
Okay,
but it's not equal to those because it's open circle.
gotcha.
And then union, bracket 2, comma 5.
And those are the only two that work?
Yeah.
Okay, now he's telling me that, not me, he's telling me this. I tested this one for sure. Okay, now I want to point out, sign analysis, powerful when you use it. Now, my goodness, if we're not finished with equations and inequalities at this point, what on earth? I'm going into functions. I'm tired of equations and inequalities, And still, no matter how many we work, we all can sit down, including me. And not being careful, make a little sign change, or miss a sign, miss it. That's what I don't like about it, because you've got to be so precise on this. Real quickly for our rates, look at the chunk of time it took. Anyone tell me, what's the answer for 1 over y greater than 0? No math required, just look at it and tell me, what must the answer be? Just merely looking at it. 1 over y greater than 0, what must y be?
Greater than 0.
Must y be positive? The top's positive already, it's a 1. So it must also, the bottom part, denominator, be a positive, so I have a positive over a positive. To satisfy this, will give me greater than 0. Is that true, guys? So just quickly looking at that, I see right now, no math required. That bottom part's gotta be positive. To satisfy, is that true? Okay. Now, look at my time here. But I'm glad we did it. Let me remind you, we got 10 minutes here before we take the break. On the handout I gave you guys, I think the first day I met you, was there one side that we have not touched yet? Had like negative exponents, strange looking problems here. I think one side was equations maybe and inequalities, on the other side was something with negative exponents floating around and all that business. I haven't touched that yet, nor am I going to touch it yet. I have it there for us, ready, but not quite ready for it today. Okay, but I will get back to that, so don't get too concerned about that. That's not going to be on the exam. Okay? Guys, any concerns here? Okay, I'm ready. Okay, Professor, got 10 minutes. We need a break. Here we go. The handout I just gave, will you please flip it over? All I want to do in these few minutes we have for the break. Functions. For goodness sake, we got a function. I'd like to have a student read the definition of a function, and in the few minutes I have, I will just discuss what's a function, what's not a function. Okay, first could I have a volunteer to read the definition on that paper which says function? Any volunteers? And I'll show you something quite quickly. Okay, go for it.
A function from a set x into a set y is a relation that associates with each element of x exactly one element of y.
And that's all they said. So I go to Stanford, they have that same definition. They're not gonna change any definitions around here. Berkeley, they have the same definition. That's what the text says, and we'll accept it. Now, if you don't mind, read it to me one more time, and I'm gonna create something as you read it.
A function from a set x into a set y is a relation that associates with each element of x exactly one element of y.
You? Step back on, here's these real quickly. Now, for the break, he tells me if I'm looking for something to be classified as a function, I'm gonna use ordered pairs. He's talking about something with an x and a y is gonna be involved. X and a y, these are coordinates. Here's my first example. Guy, read it to me one more time.
A function from a set x into a set y is a relation that associates with each element of x exactly one element.
Ooh, for each x, only one y associated with it. If that's true in this example here, I'll classify this set as a function. Is 1 paired up with 5? Is 1 paired up with anything else? No, exactly 1. 2 is paired up with 6. Did I pair 2 up with something else later on? No. And the other numbers are also just paired up with what? One number there. This can be classified as representing a function. Now, before we take a break, can anyone look at those numbers? I did it quickly though. I had something in mind as I wrote those numbers. 1 with 5, 2 with 6, 3 with 7, 4 with 8. I think I had a rule there in my mind. I was doing something to get those numbers to match up like that. Does anyone think they know what I was thinking of as I paired these up? Go for it.
What's 4?
He says you're just adding 4, Professor. You're adding 4 to the x to get the y. So he says if you want to do this, to get the y, you go back to the x and add 4 to it. And since it's a function, thank goodness after the break, we get to use a notation to show a little bit stronger than y, if it's a function, and this is a function. You get to use this notation, f of x is equal to x plus 4. That would be, those 4 will be representing that function. F of x is equal to x plus 4. F of x notation for a function. If it's not a function, you can't use the f of x notation. Okay, so we're gonna focus on that. Guys, got 5 minutes, Mr. Park. Guy, students, love you. They've been telling me how helpful you are. So guys, you send out the recordings, and I know sometimes you're busy with other classes and the lights going on, but you know, sometimes those recordings, if you look back and look at the recording, maybe you say, oh, I now sort of better understand, watching the recording. And then he also sends out, I think, sometimes he'll send out something else with the recordings, maybe some notes of some sort. I've seen him do that, formulas. And also I've asked him now to come up with a couple of extra credit problems. I've heard that, oh, some of the students hear extra credit. Oh, I get a beautiful response. When I ask you to solve this, I heard that, extra credit. Yeah, but I will place that extra credit on your test. It'll be at the end of the test, and he's gonna create a couple of problems, maybe solving an equation of some sort, or solving an inequality, and we'll give you a few extra credit points if you can get those two worked out, so they'll be placed on the test as a little extra credit, okay? Guys, I feel good about this, I feel very good about the quiz. Don't let, I shouldn't say don't let me down, don't let yourself down. I think we've done so much in this class already. You should be at the top of all the classes being taught here. You should be prepared. So I'm looking for some good scores. And from the past experiences, my students from Math 2 usually, when they're moving to Math 7, they usually are at the top. Those professors come to me and say, Ramsey, did you have so-and-so? I said, oh yeah, I had that student. How's he or she doing? A on the first test. But if they knock on my door at my office and say, Ramsey, I need to talk to you. Why? Did you have so-and-so? Give me a name. Oh yeah, I had so-and-so. Why? Did not do too well in the first test. Now, Mr. Park knows this. If you didn't, on your first Math 7 test, I will find you. I will find you. I'll say, what time do you have that class? And these professors all know each other. I know all the professors. So they'll say, oh, professor, I have it 11:30. Would you mind if I just walk in? And so one day I did walk in. I think I told you guys this story. I walked in. And my student, the seat was so that the student didn't realize I was there. And I was just standing like this. The student that the professor told me was not doing well. From my Math 2 class, you're not doing well in Math 7. And the student, finally, the other student started making a noise of some sort. And he turned around and said, Ramsey, what are you doing here? Checking on you. I'm checking on you. And now I don't say anything else, I just leave. Just leave after I say I'm checking on you. Which tells me, you gotta do something about that score in calc. You're not gonna get an A in pre-calc and move to calculus and fail the first test. Oh no. That should not happen. Or I will find you. Okay. Guys, take your 10-minute break. Got a little bit more to do, but I'll start this.